Welcome to The Explainer. So today, we're basically turning our kitchens into miniature science labs. We spend so much time squinting at nutritional labels, but today, we're actually getting hands-on to investigate a nutrient that gets a ton of attention: fats.
Okay, let's dive right into this. We all know fats are hiding inside a lot of our absolute favorite foods, right? You can read it on the label, you definitely feel it in the texture, and, well, you can for sure taste it. But here's the real culinary mystery for us today. How can we actually see them? I mean, if you don't happen to have a high-tech chemistry set just sitting in your garage, how do you prove a specific food has fat in it? Well, we're going to use good old-fashioned scientific method to figure exactly that out.
But before we start mashing things up, let's quickly lay down a clear foundation of what we're actually looking for here. What even are fats? In the nutrition world, fats are a totally key component of our food that act as a primary energy source. Just look at traditional cooking. Fats completely take center stage in ingredients like ghee, butter, and all sorts of cooking oils. They get grouped into this specific category because of the unique way our bodies use them for long-term energy storage and, insulation.
So, to know what we're testing, we kind of need to know where our targets like to hide out. The source material lists some super common, everyday sources of fats. We're talking nuts and seeds, think walnuts, sunflower seeds, almonds, and ground nuts. But it also includes everyday dairy staples like butter, ghee, and curd. When we actually run our tests today, these are the usual suspects we'd absolutely expect to give us a strong, positive result.
And just to really hit home how incredibly powerful fat is as an energy source, get this amazing biological fact from the text. Polar bears purposefully pack on a massive amount of fat right under their skin, and it's not just to stay cozy in the snow. This fat acts as an incredibly dense, slow-burning energy reserve that literally keeps them going during their months-long winter hibernation. Seriously, it lets them survive without eating a single bite of food for months. How wild is that?
And this brilliantly illustrates exactly why fats are such a big deal when we look at our own diets. Think about common packaged snacks like potato chips versus roasted graham. When we eat foods that are heavily fried or just dripping in oils, we are taking in a massively concentrated form of energy. Actually, it's a lot like the reserves the polar bear is building up, though, okay, obviously on a slightly different scale.
To put a hard number on that energy density, let's talk data. A typical fatty snack can pack a truly whopping 536 kilocalories into just a single 100-gram serving, and 35 grams of that, pure fat. Fats are just incredibly energy dense. And that right there is exactly why identifying which foods contain fats is absolutely crucial for understanding our overall energy intake and keeping our diets balanced.
All right, let's set up our test subjects. We want a really diverse group of foods to push this test to its limit. We're going to use a slice of potato, some cucumber, a piece of bread, boiled rice, boiled graham, crushed peanuts, a little bit of oil or butter, and some crushed coconut. So looking at this lineup, which of these do you hypothesize are just packed with fats, and which are mostly water or carbs? Have your guesses ready.
Now, for the methodology, it is beautifully simple, but you gotta be precise. It's called the paper press test. Step 1. Place a small piece of your chosen food right on a standard, separate piece of paper. Step 2. Fold or wrap that paper around the food and press down firmly, but be super careful not to tear the paper. And step 3? Well, this is the most critical scientific control. Think about it. What happens if the food is just wet? If it contains water, you literally have to let the paper dry completely before you can read the real results.
So the crucial point is right here at the moment of observation. After you've pressed the food and let any potential moisture evaporate, you unwrap the paper and look really closely. Does it develop a distinct, oily patch right where the food was pressed? I want you to imagine opening up that paper. Some foods are going to leave it completely blank, while others, they're going to leave a very obvious semi-transparent stain.
Now, throw your scientist hat on for a second. Let's say you press a crushed peanut into the paper, and a persistent patch stays there even after hours of drying. What do you think is the actual reason for this patch? We know for a fact the water has evaporated, so what exactly is left behind clinging to the fibers of that paper, refusing to just vanish into the air?
Well, the answer confirms our hypothesis perfectly. If oil, butter, or really any natural fat is in that food item, it forcibly leaves an oily patch on the paper. The fat molecules transfer from the food structure directly into the porous paper. And unlike water, those lipids, they don't just easily evaporate at room temperature. They are there to stay.
And to be absolutely certain,
we've got one final definitive step to this investigation. You take that piece of paper with a patch, and you hold it right up directly against the light source, like a window or a lamp. Can you see the light faintly shining through that spot? That translucence is your ultimate visual proof. The fat has fundamentally altered the optical properties of the paper, letting light pass right through where it normally wouldn't stand a chance.
Now, what's really interesting here is how clearly the data separates our test subjects. Butter and oil? Yep, an immediate oily patch, meaning yes, they absolutely contain fats. Crushed peanuts? Yes again, a distinct patch, confirming fat content. But then look at the potato and the cucumber. Zero oily patch left behind, meaning they just do not contain fats in any significant, measurable amount for this kind of test.
And this brings us right back to my step 3 of our methodology was so incredibly vital. You absolutely must distinguish between water and fat. If you press a cucumber, that paper is going to get very wet very fast. If you judge it right then and there, you might get a false positive. But watery foods will completely dry up, leaving the paper totally opaque again. Fatty foods, on the other hand, leave a permanent oily patch that's going to let light shine through no matter how long you wait.
But you know, our investigation reveals an even deeper nutritional truth. If we were to run some additional chemical tests on these foods as outlined in the source material, we'd find that peanuts don't just leave an oily patch, they actually react positively to tests for proteins too. And this brilliantly illustrates that the foods we eat are complex. A single ingredient can literally be a delivery system for multiple vital nutrients all at the exact same time.
So, as we wrap up this explainer, I want to leave you with the thought inspired by this really wise ancient saying found in our source text. It asks simply, who is healthy? And the answer it gives is one who eats food that is wholesome, in moderate quantities, and appropriate for the time and place. So, think about the results of our paper press tests. Which of these fat-containing foods do you consume every single day? Are you mindful of the immense energy they're providing you, and are you making sure to enjoy them in wholesome, moderate amounts? It's definitely something for all of us to chew on the next time we sit down for a meal. Thanks so much for exploring the science of your food with me today.